Okay, so this is a short video to show that just as we saw for the infinite square well, the solutions, the stationary states of the harmonic oscillator are also orthonormal. What does it mean? They are orthogonal and normalized. Well, how do we show that? Now, what is the equation that we use here? We have psi m complex conjugate psi n in this integral. We say that the solution of this integral is the Kronecker delta. What does the Kronecker delta mean? That this result is 0 if m is different from n, and this is 1 if m is equal to n. And so if m and n are different, these solutions are orthogonal. This integral is 0. And if m and n are equal, then is the normalization that we're familiar with. How do we show that? Well, we are going to start from this integral, psi of m. Here we are putting a plus and a minus operators acting on psi n. This is our starting point, and we are going to see where we arrive. We learned before that we can move these operators to the front by changing. If it's a plus on the right, it becomes a minus on the left. Very good. We also learned that a plus a minus act on psi n. You can see in the previous videos that a plus on psi n gives us n psi n. And so this was shown in the previous video. So let me just rewrite this. We have n, and it's a constant, so I can put it outside the integral. And here what survives is the psi m psi n dx. Okay, so this is one thing. And what we are going to play with is now this change of positions of this operator. So first I'll bring a plus to the front. And when I do that, it becomes, as we learned, a minus inside the complex conjugate. And now I'm going to do the same for what remains here, and it will become a plus. So now we have here a plus, a minus, psi m, all that inside the complex conjugate psi n. But just as here, a plus and minus on psi n gives us n, psi n, well, now here, a plus, a minus on psi m gives us m. And I can put this outside the integral. M complex conjugate, of course. Now here inside we have m psi m all inside the complex conjugate, but m is just a real numbers. So m complex conjugate is equal to m. And what survives inside? Psi m conjugate psi n. Very good. So this is what we have. Okay, that these two things are equal. All right, so let me write what we just have there. We have the n psi m psi n dx is equal to m psi m conjugate psi n. Okay. All right. How can we have this equality? Well, if n is equal to m, for sure this is true. If n is equal to m, what we have above is true, because then we are just playing with this normalization, and so that equation above just tells us n equals to m. Very good. But if n is different from m, Well, if they are different, if this is different from this, the only way for us to have this equality is if this integral is 0, okay? If n is different from m, the only way from left and right to be true is that this integral has to be 0. So then we just proved, we just proved that psi m, psi n is 0 if n is different from m, 1 if n is equal to m. In other words, we can say that this is equal to delta nm. Okay, so that's the end of this short video.